Welcome to today's video. Today we're going to be focusing on defining what a conditional statement is, a converse, an inverse, a contrapositive, and even a biconditional statement. Again, we're going to show that mastery in class by earning at least a 70% on an exit ticket. Hopefully you have the notes in front of you. If you don't, take out a blank sheet of paper. That way you can take the notes and we can get you a fresh copy tomorrow. Now, we want to talk about defining them. So, when we talk about a conditional statement, if you remember from yesterday or from the other videos, a conditional statement is if something, then something. We're going to call it if P, sorry about the smartboard, then Q. The other way to denote this is if we say P, arrow, Q. When that arrow's there, that's telling us it's a conditional statement. If P happens, then Q happens. So, when we talk about the converse of a statement, converse just means we're doing the opposite. So my original statement is PQ, so my opposite statement is going to be QP. You're taking the opposite. You're switching the hypothesis and the conclusion. And if you don't remember, just a little reminder, P is your hypothesis, so whatever comes in front of the if is your hypothesis, and Q is your conclusion. So anything that comes after the than is your conclusion. When we talk about inverse, inverse means we are going to negate it. So we're going to keep it in the same order, but we're going to make it negative. This is going to be shown, it's called a tilde or a little squiggle in front. So tilde P, then tilde Q. That just means it's going to be if not, then not. Now, one way to help you remember this is you can remember the word coin. And it's just a little acronym to help you remember that the converse is the opposite and the inverse is the negative. We also want to talk about the contrapositive. And the contrapositive, you are doing the opposite and you are negating it. So we're going to do the opposite. We're going to put Q first and then P, and we're going to make them both negative. So negative Q and negative P. The last one we want to talk about is called a biconditional. And a biconditional is when it says if and only if. It will be P, and sometimes they'll do IFF, that stands for if and only if, Q. P can only happen if and only if Q happens. Now, those are the four types of sentences we want to talk about. So now we want to look at some examples of what this looks like when it comes to sentences and words. Now, if we look at our example, we have if I win, then you don't lose. So we're going to start by labeling our two parts. If I win is my P, or my hypothesis. You don't lose is my Q, or my conclusion. So now we want to be able to write the different ways. When we talk about converse, again, this is the opposite. So it's going to be Q and then P. What that means, my statement is going to look like, if you don't lose, then I win. All we did was flip the P and the Q. Now, the inverse means we negate it, so we're going to keep it the same order, but it's going to be negative P and negative Q. This becomes, if I don't win, then you lose. Think about negating it as making it negative if it is, or if it is a negative, make it positive. Two negatives make a positive, just like in math. We don't want to say, then you don't lose. You can't have two negatives. We still want proper English. So the opposite of you not losing is you losing. Now the contrapositive, we want to negate it and do the opposite. So it's going to become negative Q and negative P. So in this case, if you lose, then I don't win. And if you look, the contrapositive, you can either take the converse and make it negative, so do the converse and then the inverse, or you can do the inverse and then the converse. Either way it works. Now, when we talk about true or false, this is what we're also going to call logically equivalent. And you're going to hear it written either way. When we say logically equivalent, if my original conditional statement is true, then my contrapositive is true. If my original conditional statement is false, my contrapositive is false. So if I look at this example, if you don't lose, then I win. Well, that's false. That means the contrapositive is also false. The other logically equivalent statements, if I have the converse is true, then the inverse is true. If the converse is false, then the inverse is false. If I look here, the converse is if you don't lose, then I win. Well, that's false. So then the inverse is also false. Only the conditional and the contrapositive are logically equivalent, and the converse and the inverse are logically equivalent. Now in this case, everything is false, but you still have to make sure those are the only two sets that are logically equivalent. Our second example, if two segments are congruent, then they will have the same length. Our converse, again, we want to flip P and Q. Well, if I look, my P is two segments are congruent. My Q is they have the same length. So my new statement is going to say, if two segments have the same length, then they are congruent. All we did was flip them. And make sure it still makes sense. We don't want to say if they have the same length. Well, we don't know what they is. Now the inverse, we want to keep the same order, but we want to make them negative. So if two segments are not congruent, then they do not have the same length. That not is your key word. When we talk about contrapositive, we want to both do the opposite and negate it. So if two segments don't have the same length, then they are not congruent. And again, for true or false, you want to look at the conditional and the contrapositive. They should be the same. And the converse and the inverse, they should be the same. Please bring your notes and any questions you have to class tomorrow. We will do more examples, and I look forward to seeing you then.